Every decision carries consequences. Some you can see, others remain hidden until it's too late. In today's data-rich environment, the challenge isn't information, it's insight. What if every decision you made was backed by the power to see its impact before implementation? This is the power of Simio's intelligent digital twin technology. Our object-based, data-driven simulation platform creates a dynamic replica of your entire operation, continuously updated with real-time data from your systems. When you need to make critical decisions, Simio lets you simulate every possibility, change resources, adjust schedules, modify processes, see the results instantly. Our predictive analytics engine doesn't just show what might happen, it reveals potential risks and recommends optimal solutions. From reducing costs in manufacturing to optimizing patient flow in healthcare, Simio transforms complex data into clear direction. As technology evolves, so does Simio. Our commitment to innovation ensures you'll always stay ahead of what's next. Don't just hope for the best, know what's coming. Simio. Simulate what if with an intelligent digital twin. Visit simio.com today to discover how our digital twin technology can transform your operation from reactive to proactive, from uncertain to confident.
Hello and welcome to the Simio Solutions Series 2025. Today's session is using the Python scripted step in Simio 19, a deep dive. My name is Dan Vasilini. I'm the Vice President of Global Sales over here at Simio. But doing most of presenting today is going to be Jeff Smith. He is our Vice President of Training and Academic Programs. Our emails are posted here on the screen in case you do have any questions or anything you'd like to talk about in regards to today's session that does not get answered or addressed. You can feel free to reach out to us via email. A few housekeeping items before we get started today. Today's session is being recorded for replay purposes. If you'd like to rewatch this session or recommend it to a colleague or a friend, please feel free to refer them on to simio.com. On simio.com, you'll see right across the top side of the screen, there is a learning drop-down tab. Under that learning drop-down tab, there is a solution series webinars area. In that area is every webinar we've done over the course of the last 3+ years. We've been doing these about once a month since 2023. So you'll see a lot of content. There's 30+ of these out there. You can go back and watch any of them. Included with those sessions, if we've done any type of modeling or any models that can be used for public consumption, we've also included those models in the same area where you can get to the recordings. Please note, you will be muted during today's presentation. If you do have a question to ask, there is a little Slido polling area. Should be, at least on my side of the screen, it's on the right side. You can go in there and type your question in. Those questions come in. They are private when they come in, and we will plan on doing a Q&A session at the end of today's session. We generally will leave about 5 to 10 minutes for questions. We'll try to get to any questions that come in. We have this session scheduled to last today about 60 minutes. The presentation itself will go in the neighborhood of 45 to 50 minutes, thus leaving that 5 to 10 minutes there at the end. All right, one more session for 2025. That session will be a little less than a month from now on November the 12th. It is going to be another deep dive session like we're doing today here on Python. Now, this is where audience participation and polling comes into play. We did a Simio 19 release webinar in the middle of September. In that session, we highlighted 4 new items. We also asked for participation during that session and said, what would you like to see a deep dive on? And the overwhelming response came back with the Python session we're doing today. Second, we had basically a tie from what would have been next. So what I'm going to ask is at the end of today's session, we're going to do another poll, and we're going to ask you to vote on what we're going to do here on November the 12th. We had bypass, which is optimization functionality that's in Simio, and we had materials handling, which has been updated in Simio 19 as well. So we are going to put those 2 topics on there. Would like you to give some feedback at the end of today's session. Please give us a vote on which one you'd like to see, and then that will be what we will cover on the November 12th session. So we'll be releasing that pretty soon after this session ends today as far as what we will be doing on the 12th. So once again, audience participation, please give us your vote. Please let us know what you want to see, and we will accommodate. And this will be our last session here for 2025 on November the 12th. So I want to thank you for attending. We look forward to your vote here at the end of the session. Please put any questions in like I had instructed earlier, and I will turn things over to Jeff. Thanks again.
Welcome to the Simio Solution Series. My name is Jeff Smith, and I run the training and academic programs team at Simio. And the topic for this Solution Series presentation is using the Python scripted step. The Python scripted step is a new feature that was introduced in Simio 19, which was released in September of 2025. Hopefully by the end of this presentation, you'll understand the new Python scripted step, how it works, and some of its basic features. And we'll also see the scripted step in action through several hands-on examples. Note, however, this is an advanced feature of Simio, and so we assume that you already know how to use Simio processes and that you already know Python. And so we won't be spending time during this presentation on either of those two things, although you will see both in action. A Python scripted step is a custom step where the logic for that step is defined using Python. Once defined, the step can be used in Simio processes just like all other Simio steps. So let's jump into Simio and have a look at the Python scripted step in action. Python scripted steps live in the definitions tab in this new scripted step section. So you can see I'm in the definitions tab here, and I go to the scripted step section here. And to create a new scripted step, you simply click on the Add Step button. And this is the step that was created, my step 1. So the next thing I want to do is look at the Python code that was created when I did that. And so I'm going to click on the Edit button. But before I do that, let me show that a prerequisite to using the editor is defining the path, the file path to your IDE. So you can see go to the File Settings menu down at the bottom, you see Scripting, and here is the path to the IDE, in my case for VS Code. And so once you set that path to your IDE, you can then click on the Edit button and it will bring up the Python IDE and the code for the scripted step that we just defined. When the scripted step is executed in your Simio model, the execute function from this Python file gets executed. And so we're going to talk a lot about what that template involves and how that code, how to interact with that code. But before we do that, let's just go in and make a simple model that uses that step. So I'm going to make the simplest possible model. So I'm going to make our favorite source server sync model. So let's put source server sync, connect them up with paths. And then I'm going to go to my source and have a stopping condition of 3 entities. So I'm just going to create 3 entities. And then I'm going to change the ending type to unspecified. So I'm going to create 3 entities, and when they depart the system, the model will terminate. So I just run it and check that that's the behavior that we have. So I run my model. Oops. And there's the first entity, second entity, third entity left, end of run, exactly what I expected. So let's go in our model and add a add-on process for the server. So I'm going to go to the server, add-on processes, and I'm just going to add for the processing add-on process. So I'll just double-click there to create the process. And now when I go look at my step list over on the left side here, you see the new scripted steps section. And there is my step 1, the step that we just created. So I'm going to place it there, and I'm going to use a color so that it will stand out. I'm going to initially run our model in trace so that we'll see that occurring, that step executing, and so then we will see that in orange. So I'm going to go back to my model. So now we've added that, and now when our entity arrives and is processed, we should see that scripted step execute. So I'm going to turn on model trace so that we can see that. Expand this window just a little bit, and now I'm going to run. And now there you can see the orange going by, so our model's finished. So let me just scroll back to the top, and you can see there's our first execution of our scripted step, and then our second one should be here, right there, and then our third one is right there. And so before we go on, I'm just going to do one other thing to simplify the debugging and observing how these scripted steps execute. So I'm going to turn trace off, but I'm going to leave the trace window open. I'm going to go back into my process and select my scripted step instance and go to the advanced options under this trace level option. And I'm going to set that to always. And so what that does is it says, I always want to trace this step, even if the trace is off. And so now when we run our model, we don't see the trace except for that single step where we set that trace level to always. So back to our scripted step. And note, when we created this or when we ran the model, we didn't make any changes to our Python code. So we just executed the code that was copied in as part of the base template. So let's have a closer look at that. So I'm going to go back to PowerPoint where I have the scripted step template. So this is the code that gets copied in every time you create a new scripted step. You can see we do some imports from Simio API, and then we define this single function called execute. We pass two parameters, something called property readers, which is an instance of iProperty readers, and the context, which is an instance of iStep execution context from the Simio API. And then there's one line that gets executed, and that ejects the information to trace. So it's just context, the iStep execution context, .execution information, .trace information, and then the string that you want to have printed to trace. So, for example, if I go back in and modify this, so let's say executed and just say modified, and then I save the script, so I just saved the script file, and then go back and execute, and now you can see that we are printing, or we're showing that new line in trace. And so creating and using scripted steps is basically adding the step and then editing the Python code to implement the logic that you want. Of course, the most important part of doing this is passing information back and forth between the Simio model and the scripted step, so that in the Python code I have access to states and properties and objects in the model, so that I can implement the logic that I want to have in my step. So we're going to see that next in another example. But before I do that, let me just mention that we also have, go back to PowerPoint here. The Simio help describes in detail how the scripted step works. And here you can see descriptions of those two parameters that get passed, the context and the property reader. And we also have, as part of the Simio GitHub repository, a set of 8 example models and corresponding Word documents. And so you can see I have a Word document corresponding to each one of the models. There are a couple models that don't have Word documents, but the first 8 do. And it describes in detail the implementation and what's going on. And we're going to start out with looking at just one of these, something called server selection model. So the server selection model, again, the model itself, the SPFX file that I'm going to show is available from the GitHub repository that I showed. The goal here is that when an entity arrives at the source, we're going to select the server with the shorter queue. And we're going to default to a preferred server if the queue lengths are equal. Now, I could easily implement this using the source object. Using the output node, I could specify, that exact thing to go to the one with the shorter queue. But in this case, what I want to do is I want to define a Python scripted step so that I can make the decision inside the scripted step. So the first thing that I need to know is, well, what information do I need to make that decision? Well, I need to know the server 1 queue length, I need to know the server 2 queue length, and I need to know the preferred server to use in case that the queue lengths are equal. And then I'm going to, in order to implement the selection, I need to specify, well, which server was selected. And then I want to change the entity symbol, because you can see in my picture here, the entities going to server 1 are red, the ones going to server 2 are blue. And so just as a clue, we use Simio expressions to define these things. So the queue lengths are server1.inputBuffer.contents, server2.inputBuffer.contents. And then to implement the selection, I'm going to use the token.return value from the from the process. And to set the entity picture, I'm going to use the model entity dot picture state. So to implement this, using a scripted step, the information that we pass from Simio into the scripted step, we use step properties. And to implement our selection, in this case, we're going to use state. So we're going to use the selected server as a state, which is going to be the token return value. And then we're going to change the entity symbol by just setting the model entity.picture from within the scripted step. So here is our Simio model. You can see I have server 1 and server 2. I have a couple of controls here, reference properties, the number of entities to create, how many entities we're going to create before the model terminates, the preferred server, so we can let the user specify which server to go to if the queues are equal length, and then I have a model version property that we're not using. So if I just click go, you can see I have the preferred server set to 2, so entities are going to go to server 2 when the queue lengths are equal. If I set that to 1, you can see the first entity and subsequent entities are going to go to server 1 when the queue lengths are equal. Okay, so the model is set up exactly like I mentioned, but the thing that's different here is that we're using a scripted step to make that decision. So here when I create the entity, you can see a process where I do a notify. So we have a notify to print some information to trace, and then I have the scripted step. And then based on the return value, which is token.return value, if that's equal to 1, I set it to server 1. If it's not equal to 1, then I set it to server 2. And so inside the scripted step, we are setting that token return value, and we're also setting the model entity dot picture value. So let's have a look at the scripted step. So go to definitions again, scripted step. You can see I've named it choose server. And unlike the example that we did before, we have properties associated with that, with the scripted steps. We have the 3 pieces of information that we said we needed to pass from Simio to the script in order for it to be able to make the decision, the 2 queue lengths and the preferred server. And then we have this model version string that we don't use. And our 2 queue length properties are expression properties. Our preferred server is an integer property, so it'll either be 1 or 2, and our model version is a string property. So when I go look at the process and I choose my scripted step, now you can see those properties associated with the step, where the step instance where we put the values. And so here's where we're using those Simio expressions. So for S1 queue length, we're using server1.inputBuffer.contents, the expression for the number of entities in the input buffer. For server 2 queue length, we're using server2.inputBuffer.contents. And then for preferred server, I'm using the reference property preferred server. And for model version, I'm using the reference property model version. So let's have a look at the Python code for our choose server scripted step. So remember, we go to definitions, scripted step section, and hit the edit button. We'll bring up our editor. And now here is the choose server Python code. So it's a little bit more code because we have to read the information in and then make our decision. And so you can see I've commented the code here. Tried to comment it enough where we can see what's going on. So the first thing that we read is the model version. Again, I mentioned here that we don't use it in the logic, but we might in the future. So to get the model version value, that's where our property reader comes into play. So we have our property reader is one of our parameters. And so we use the get property method and specify that model version name. And so if you go back to our Simio here, we see model version is the property name. And so we're using that property name in the property reader. And then it's a string value, so we just use the get string value, and that's our model version. We do the same thing for preferred server, except it's an integer value. And so the values are stored as double values, so they're either strings or double values. And so we read the double value and then cast that as an integer. And then we print to trace the model version and the preferred server. And so if we go into the model and run that, you can see that print So let me just go and turn trace on. So I'm going to just open the trace window, actually. You can see the remnants from last time, and I will just set this to one entity, so we just see it one time. So set our max number to create as 1, execute our model. Our one entity is come and gone, so the model stops. And you can see 2 entries in our trace. We have our notify, and then we have our choose server. The choose server, this is the line that we just looked at, so it prints model version 1A, which was read from this property, and the preferred server was 1. So if I go in and say, let's change the preferred server to 2, and then execute, we can see now the preferred server is 2. So next in our code, we are going to read our 2 queue lengths. So these are also integer values, so we read them using the property reader, get double value, and then cast as integer. And then we are keeping track of the entering value of our context return value. So context.return value is the return value, is the token return value for the executing token. And we are reading the 2 queue lengths and saying, implementing our shorter logic. So if queue length 1 is equal to queue length 2, set it to the preferred server. Otherwise, if queue length 1 is less than queue length 2, set it to return value to 1, so server 1. Otherwise, set the return value to 2. So it's choose the preferred server if they're equal. If 1 is less 1, otherwise set it to 2. And then, of course, we trace that information back so that we see that in the trace, which we saw before. So here's our trace, and here's that second line saying that the 2 queue lengths are 0, because this is the first entity that arrived. The entering value for our return value was 1, but our preferred server was set to 2, and so we're choosing the preferred server as 2. And so the implementation of that server selection is right here that we show printed out here as this leaving value. So we go back to our Python code, and you can see that we have set this context return value to either 1 or 2 based on the length and the preferred value, and we're just printing that out right here. And so what happens in our Simio process, once we execute, we then can decide on that token return value. So in the case, it's either going to be 1 or 2, and it will have been set in the Python code. And so the last part is to set the picture symbol. So go back to our model just a sec. Let me go back to the Simio model. And you can see that let me stop this model, and our default entity has 3 symbols, 0, 1, and 2. So we want to select picture 1 if it goes to server 1, picture 2 if it goes to server 2, and that's where we're getting the red or the blue. And that happens right here in the code where I'm using the context associated object. And so recall the context is the step execution context, and it has a property called associated object, which is the associated object of the token that's executing the step. And then I say of that associated object, I want the picture state. So that's what picture is, and then I can just update its value. And so note here that I have used the associated object for the context and then said, I want the picture state. And then by setting that value in the Python code, it in turn, the value is set in the Simio model. And so that's why the entities that go to server 2 are blue, and those that go to, if I get a 10 here, those that go to server 1 are red. So hopefully at a high level, at least at a conceptual level, this makes sense, that we are passing information that we need to make the decision in the Python code, the server lengths and the preferred server. We're then making that decision using Python logic, and then we're implementing our selection by setting state values. What might not make so much sense is how we decide the exact syntax. So for example, when we go in our Python code, the property readers get property and then get string value, get double value, how we know that context.return value corresponds to the token.return value state. And then the simplest part about printing to trace here that context.executioninformation.trace information is what we need. Well, that is the implementation from the Simio API. And so if I go back to my Simio model and go to definitions, scripted step, you see that we have a button for the Simio API reference guide. And so if we open that, and then we can look at the details of that reference guide. So for example, if I search for the I-step execution context, which is what context is, I can then see the interface to that. So here is our execution context. Here's the return value. So here's where it says gets and sets the return value of the executing token. Here's the associated object that gets the associated object of the executing token. And because of where this step is, that associated object is in fact the entity. And then we can go look further at that associated object and say, okay, this is of type iElement data. So I go to iElement data, and then here's the state collection, and so on. So basically, the syntax that we use for accessing that information, both retrieving from the properties and then saving the values to the states, is defined as part of the Simio API reference. So learning how to use the Python scripted step involves understanding how that API works. And more importantly, at least when you get started, is how to get that information from the Simio API reference guide or from the set of example models that I mentioned earlier that we have in the Simio GitHub repository. The second example that we'll do is interacting with a server object. And this example model is not on the GitHub repository, but it will be available on the solutions page where you'll see this recorded video. And in this model, we're going to do several things that we didn't do in the previous one. First of all, we're going to have multiple scripted steps. So we'll have one scripted step that we use on run initialize to get things set up. And then we use another one in the process step to make some changes. The second thing we'll do differently is we're going to pass an object reference property so that we can interact with the object within the Python code. So rather than just reading the property, we're going to read the object reference and then interact with the underlying object. I'll also demonstrate or talk about how to use the print statement to add debugging messages for your code, and then I'll demonstrate using interactive debugging with VS Code. When you use the standard Python print function within a scripted step, it prints the string that you specified to the function, to the Simio actions log file. And this file, the default path for that is the your username, app data local, Simio LLC, Simio, and Simio actions log. And this is a log file where Simio prints various pieces of information about Simio running. And you can see an example of that here. So this is just information about as Simio runs. And so one thing that I do in my models is I use a helper function where I add a searchable tag. So you can see here that I have defined an lprint function, and I just prepinned script print in brackets to the string that you pass it. And so what that lets me do is search the log file for this tag so that I can easily identify those pieces of code where I use the print statement. So let me just scroll down to the bottom of this one. Here you can see a set of those where I had script print, script print, script print, script print, so on. So these are, each one of these lines represents output from that print file. And so I use that in a script in a Windows command file so that I can monitor that file. And you'll see that as I go through this example. Also note that the script that I use is also available for download with the model. So you'll have the model and you'll have the command line print should you choose to use that. So here's the Simio model, and it's a pretty simple model. I start out with a source server sync, what you see in the label here is the current capacity of the server. And what the Python step does is change the server capacity based on the queue. So when I run my model, you can see we start out with capacity 1. Then as the queue builds, we increase capacity. Now we're at capacity 3, capacity 4, and then we drop back down to capacity 1. So it's just a simple monitoring step that increases capacity when we need it and then decreases capacity when we don't need it. So looking at our Python steps, I'm going to go to definitions, scripted steps. As I mentioned, we have two steps. We have my step 1 and my step 2. And then if I look at the processes, my step 1 is executed in on, run, initialize, and my step 2 is executed in server processing. So go look at those steps. My step 1 has a single property, the object instance property, and my step 2 has two properties, the object instance property and then the numbering queue, the same expression property that we saw in the previous model. And so if we go look at the implementation, the step instances, in my step 1, we simply pass server 1, and in my step 2, we pass server 1 plus that expression for the queue length, which is server1.inputBuffer.contents. And so we go look at the Python code. So go to scripted steps and edit, and we can see our two files here, my step1.py and my step2.py. And notice in the code, I use the lprint function that I mentioned before. So I have lprint that just prepends my string with script print, and I use that more often than I do the trace because I find it more convenient to use that log file to do debugging and see what's happening in my script where I want to versus writing to the trace file, but both will work. And so what you see in my step 1, which gets executed in on, run, initialize, is we're just seeing what's happening inside our server. So we read the property, which is object instance property, and then we just print some information about that. So we print the property string. So we print it as a string value, and then we print it as a double value. And then we know that this is an object reference, so we then cast that property as an intelligent object property. And so we then tell Simio, through the API, I want to get the intelligent object reference. And so now objref is the object reference. And from that object reference, I can get the initial capacity, which is a property. So I use get property initial capacity. So note that we haven't passed that as a property in the step. We are getting that information directly from the object. So we only pass the object. And here we're reading a property, and then we're reading the current capacity state. So from the object reference states collection, give me the current capacity, and then I print those two out. So if I go back to my model, one more thing is here's the script. I'll show this. Here's the script that I use to monitor that log file. Print. And so now it is monitoring that log file for script print lines, as we say here. So if I go back to my Simio, and what I'm going to do is I'm just going to click on step. And so when I execute the step, it then executed on, run, initialize. So if I go back here, you can see the output from my lprint statements. So I'm executing mstep1. Here's where I print out the property value, the actual property string value and property double value. Here's where I get the object name, the initial capacity property, and the initial current capacity state. Going back to my Simio model, I will stop it so that we can then go look at the second scripted step. So again, my step 2, I pass the object property and the expression property. And so if I look at that code, you can see what's happening. Oops, pull that up here. There we go. In my step 2. And so we use the same lprint function that I had before, and we get the object reference just as we did before. I'm now reading the numbering queue, so that's our second property that we pass in. And so now I have a reference to the server object, and I have an integer that for the numbering queue. And so now I want to read the state, the current capacity for the object. So I just use object reference states current capacity. So the states is a collection of states for the object. And then I extract the current capacity. And then I cast that as an real state. Then I can ask, what is the numbering queue? Is it greater than 2? Then I want to increase the capacity. So here I'm getting a state value, and here I'm setting the new state value. Otherwise, if there's 0 in the queue and the current capacity is greater than 1, I'm going to reset the capacity back to 1. So I'm just doing that adjustment of the current capacity state based on how many entities are in the queue. And then finally, I just print out the numbering queue and the current capacity. And then I also then execute the default trace line that was in the standard template. And so when I then run my model, if I go back to my Simio and run the model, and then I pull up my script print, you can see when we increase the capacity or decrease, whenever an entity is processed, we print out that we are executing my step 2, the current numbering queue, and then set that current capacity. And so key for this model, again, was that we were passing the object reference property, in this case for the server, and then from that object reference property, we were able to retrieve the property, the initial capacity of the server, and the state, the current capacity of the server, and then we could modify the state. Also, again, I demonstrated using the print to add debugging messages. I find that a little easier than using trace, but note that we could have just as easily in the code. So let me pull back up the code here, the Python code. Instead of using lprint to print the context information, we could have just as easily printed it to trace. So if you find that easier to print to trace and to use the trace to get information from the running model, that functionality is there for you also. So the last thing we want to talk about in this model is interactive debugging using VS Code. Back to our model, and I'm going to open the scripted step page under definitions, and note that we have this enable debugging button. The debugging functionality uses debug.py, a standard debugging package, and so theoretically any IDE that supports debug.py type debugging should work with the Simio scripted steps. We've tested it extensively with VS Code, and so my recommendation is if you don't already have a favorite IDE, then you might as well use VS Code, since that's the IDE that we've done the most testing with. So to do interactive debugging, what I need to do is I need to enable debugging in my model, and then I'm going to go in my Python code here, and I'm going to set a couple of breakpoints. So I'm going to go in the step 1, which is run initialize, and I'll just put a breakpoint right here. And then I'm going to go in my step 2, and I will put a breakpoint. Let's put a breakpoint right here where we get the object reference. So we have the 2 breakpoints set. And so now I have enabled debugging set. So when I go back to my model and run, I'm going to get a message saying it's in the process of enabling the debugger. I'm going to get a message saying, okay, attach Python to debugger. So I go back to my Python code and go to run start debugging. And you'll note here we have this pinkish bar here that says the remote debugger is attached. And so now we can go back to our Simio model and say, okay. And now our model is executing, and we are initializing. And so if we go back to our code, we see that we're at the breakpoint right here. So our execution is stopped at the breakpoint, and we can then look over at the variables and say the initial capacity that we read right here has a value 1. Here's the object reference, here's the context reference, the property readers, and so on. I can then continue executing the code. And now we're in my step 2. So we have left on run initialize. We go back to the model. We can see that our first entity is at server 1 right now. And so we are stopped at the debugging step there. And so here we are at this step, and we can step over and then watch and do typical interactive debugging. So we can see exactly what's happening. We can go line by line. We can go inside functions and so on. In this case, I'm sitting here right here at the if statement, numbering q greater than 2, and I can look at the current value, so we know it's 0. So it's going to step over into the else, and now numbering q is equal to 0, which of course it is, and current capacity value greater than 1, which it's not. And so when we step over, we see that we did not reset that value, and then we just continue on with the execution. So I'm going to get rid of the breakpoints, and then go back, and now we are executing the model. So I'm going to go back, and I will just stop the model here. Well, I'm going to stop the model. I got to go back into the code. I'm stopped here, so let me just again execute. Now go back to Simio, and I'm able to stop the code. Note that the debugging setting is sticky, so if I go back to definition scripted step, we see that enabled debugging is still highlighted. So if I run the model now, it's still going to go through that debugging step. So I could go back into VS Code, start the debugger, and so on. Or I can just, if I don't want to debug, I can just start the model, then stop the model, and it will run and stop. And then I can go back in and uncheck the debugging, and now the debugger is disconnected. So using the interactive debugger is a very powerful tool to debug your Python code and to try to get an understanding of how the data structures are set up, so that in conjunction with the API reference guide and the capability to either print to trace or print to the Simio actions log, that's the set of tools that you'll use to debug your Python steps. The last example model that we will look at in the Solution Series presentation is also from the GitHub repository, and it's using model global data. And in this model, we're going to do 3 things that we haven't seen before in our previous models. First of all, we'll use an external Python package. In this case, we will use pandas. And secondly, we will show how we read a data table in a Python step. And again, in this model, we're going to read a data table and create a pandas data frame that mimics that data table. And then finally, we will show how we use model global data to store and retrieve data structures between Python scripts and between Python scripts execution. So what we're going to do is read a data table and create the pandas data frame. We'll store the pandas data frame as something called model global data so that we can easily retrieve the data frame so that we don't have to reconstruct it every time we want to access it. So this is a very powerful function that I think you'll use quite often as your Python scripted steps get more and more complex, because we want to be able to build data structures that support data processing and data analysis and so on, and then use those data structures as the model executes. Here is our model, again, using model global data v01. This came directly from the Simio GitHub site. And it's a very simple model where we have a source, a server, and a sink. And if we look at the source, we create a number of entities specified by a reference property. Here I have it set to a value of 2. So we're going to create 2 entities. They're going to go to the server and then the sink. And if we look at the server, our server has a processing add-on process. If we look at our scripted steps, we have 2. We have something called model global data. And for that scripted step, we have two properties. The first is a table property, where we specify the table that we want to use. And the second is rows to trace, which specifies how many rows of the table do I want to print to the trace while I'm doing the build process. And then we have retrieved data frame in global model data, and it doesn't have any properties at all. And so we look at our processes and we see that we execute model global data in on-run initialize. So when we start the model, we're going to execute this step. And then when an entity is processed, we first notify, and then we execute retrieve data frame in global model data. So if we look at our data tab, we see we have a data table named items. And the items table is the one that we're going to read. We have two other tables that we don't use in this model. And so if we look at our processes, when I look at model global data, I pass the items table as the property name, as the property items table, and then I use the reference property rows to trace. And so when I run my model, before we look at the Python code, we'll just run the model and you will see that I'm using, I'm printing to trace. So we have model global data in blue, we have a notified orange, and then we have retrieve data frame in green. And so when I run, you can see in our trace, we have our blue code, which is the on-run initialize. So we're creating the data structure. Then we're processing two times. We have two entities. So the orange is the notify step, and the green is the Python scripted step code. So now that we've seen the model run, let's have a look at the Python code for our two scripted steps. Just going to reduce that trace window a little bit, stop the model, go to definitions, scripted step, and hit the edit button to open our text editor. And we see our two files, one for model global data, which is the function or the scripted step that's called in on-run initialize, and then retrieve df in global model data, which is called as the process add-on process for the server. So let's start with the model global data, which is where the lion's share of the work in this model is done. So you can see in the code that we define two helper functions. One is called get df from table, and the other one is called show first rows of df. So I'll talk about those in just a second, but let's talk about the basic execution sequence. So when this step is executed, we read the rows to trace, and this is telling us, as I read the table, I want to add to trace some number of rows of that table just to see what's happening during the read process. So we're reading that in as a property on the step. Then I'm making a call to our helper function, get df from table. And so what I'm sending it is a list of the property columns. So we have item number, item name, rack, and node. I jump over to the model. We see that those are the columns of our table. So those are the property columns of our table. Go back to our Python code. We have an empty set, and the empty set or the empty list is our list of state columns. So this table doesn't have any state columns, it only has property columns. Then we pass the property name, so this is the scripted step property name, the context, the property readers, and then finally the number of rows to trace. So we pass all of that information to our function, and it returns to us a pandas data frame. So if I go take a quick glance at that function, you can see what's happening. I'm using the name of the scripted step property to retrieve the property and cast it as a table row reference. Once I have the table row reference, I can then get the table row count, and then I can iterate through the rows of the table, constructing our pandas data frame. And so that's what happens in this last step, where I create the data frame using the row data, and then I return the data frame to the calling function right here. And so we end up with df items is of the pandas data frame of interest. And so I then print to trace the number of rows in the data frame. So this is our data frame length. And then I call our second helper function, which is show first rows of data frame. So I give it the data frame that I just constructed, the context, and then the number of rows to show, and it just concatenates those together and shows those. And then finally, the important step where I'm writing this to model global data. So now that I have my items table, I've constructed the pandas data frame by going row by row from our Simio table. I'm going to write that to model global data. So in these two steps, I retrieve model global data, and then I set the data using the name items table. And so if I go back to my model, this is what happens in this blue step. So recall that the color blue is the scripted step that gets run in onRun initialize. And so here are our 7 rows to trace specified by this rows to trace property. So we just trace those 7 rows. Then we print the number of rows, 700 rows. Then we print the first 2, so we concatenate the first 2. And then finally we wrote the items to model global data. So that's how we construct the data frame construct the pandas data frame from the table and then write that to model global data. When we execute the second add-on process, so in our Simio model, when an entity goes to the server and that server process add-on process is executed, that's what happens. Then this function, this Python script is executed. And so this is a much simpler script because all we're doing is we're retrieving the data frame from model global data. So instead of rereading in from the data table and constructing the data frame, we just read it in from model global data, and then we print the relevant information to trace. And that's what you see in our trace function here in the green color. So we read items table to model global data. It has 700 rows, so it's the same data frame that we wrote in the onRun initialize. And then we just concatenate the first 5 rows together so that we can see those rows from our data frame. So it's a very straightforward process where we're constructing a data structure in onRun initialize, and then we're sequentially accessing that data structure in other steps within our model. In this model, we don't really do anything. We just construct the data frame, and then we just demonstrate that we have retrieved it by printing some rows. But in more complicated models, I would be using that data structure that I retrieve for doing decision making or implementing other process logic. The last thing that I'll show in this model is how we tell Simio that we want to use the external package, in this case, pandas. So I'm going to go back to our code, so go back to definitions, and then edit the code, bring up our code, and you can see that we have 2 lines here that involve the pandas package. We have the standard Python import statement where we import pandas as PD so that we can use that package in our code. And preceding that, we have the pound package pandas. And that declaration tells Simio to install the pandas library in the temporary Python library. So the way Simio executes Python is it creates a temporary Python environment when you open a model or when you add a scripted step to the model for the first time. And when we add the package declaration and then specify the package, that tells Simio that we want to install that external package. And once you do that installation, you're able to do the import as you normally would in Python. One note that when I add this pound package and then the package name like pandas and hit Control-S to save the script, you might have a delay, a minor delay while Simio goes out and retrieves that package. It's either going to retrieve it from a cache if you've used that package before, or it's going to go out and retrieve that package just like pip normally does when you're constructing your own Python environment. So that concludes the presentation of our using model global data example, which is our last example in the presentation. So in summary, let me say that the Python scripted step is a comprehensive feature with a lot of functionality, a lot of features, and so there's a lot to learn in order to use these features. So we have several different resources. The most important resource to get started is our GitHub repository. And so let me again repeat that in that GitHub repository, we have a set of example models. We looked at 2 of those in this presentation, the server selection and the using model global data. And for most of these models, we have a corresponding Word file. So we have a Word file for server selection, we have a Word file for using model global data. And in these Word files, we go through step by step how to construct these models, how to interpret the properties, and so on. So all of the things that you're going to need to learn as you start using this feature. We also have Simio help. We have discussion about how to use the scripted step, and then all of the technical details. The Simio API reference guide, when you're looking at how to access information in the scripted step from the Simio model or pass information back and forth. That's the guide that's going to define how all of those things work. And then finally, through my account, you can submit support requests, and then we'll have additional information and additional example models, training involving the Python scripted step, and other materials available to assist in your learning.
Great, thank you, Jeff. All right, we have a lot of questions that have rolled in. I know we are at close to the end of time here, but let's get through as many questions as we can. So go ahead with the first question. All right, Jeff, where are the Python scripts stored? Is it stored within the .spfx file or in a file path location? And does Simio install its own Python environment, or can it interface with the current install?
Thanks, Dan. So these two questions are obviously related. And the way Python is used in scripted steps is we install a Python interpreter in a temp directory. Every time you open Simio where the model has scripted steps, or when you add scripted steps. So in that temp directory, we install Python and the libraries that are required and so on. We cannot currently interface with an external Python environment. So if you have your own, there's no way to tell Simio to use that. You have to use the one that we install. In terms of where the scripts are stored ultimately in the SPFX file. And so when you open a model that has scripted steps, that the Python files and any data files that you include are created in that temp directory, and that's what you see. That's what you saw in the video on my VS Code. When I was going to VS Code, I was looking in that directory, and the scripted steps are included in that directory. And so if you create the scripted steps and edit the scripted steps, they show up there. You can also add Python into that directory, into that temp directory, and then that Python that you add will be saved as part of the SPFX file, so that when you reopen that file, that directory structure will be recreated.
Okay, perfect. Thanks, Jeff. Next question. Would it be possible to fully develop a model in Python without the UI and later spin the UI for presentation purposes?
So that's not really how the scripted steps are designed in the current implementation. So how a scripted step works is that it's like any other Simio step. So it's executed as part of a Simio process, and it's executed in zero simulation time. So these are, from a simulation perspective, instantaneous events, and it then is executed in the using the Python logic. Now, what you could do, and you can do in the Python scripted steps, is you can add events to the future event list, to the event calendar. And so you could conceivably construct a simulation using a series of Python steps, but it's really not designed with that functionality in mind. Instead, it's designed to incorporate state information from the model in its current state when the step is executed. Execute some logic, implement some of the decisions, either using states or data tables or something like that, and then again return to the normal execution sequence of the Simio model.
Okay, perfect. All right, I know we're getting short on time, Jeff. What do you think? You want to hit like 2 or 3 more questions?
We can do a couple more if you have any.
Okay. All right, next one, please.
Be done.
Do you need a Simio license to use the Python API?
Yeah, so the Python API that we're using here is internal to using scripted steps. So it's going to be subject to the same licensing requirements. So the short answer is yes, you have to have a Simio license to be able to execute the code.
Okay, perfect. Next one. All right, I think that's the end of the questions. So look at that, right on time, exactly at noon. As mentioned at the beginning, as you exit here today, we are looking for your feedback / suggestions / your vote on our next session, which will be in about 3 weeks. So if everyone could please, as you log out here, give us your vote on the next series, whether it be on the bypass or whether it be on material handling, that would be awesome. Otherwise, we'll see everyone again in about 3 weeks. Thanks again. Goodbye.